All right, part three. So we just looked at calcium balance in our body fluids. We're going to look at what happens when that gets out of balance. So two conditions we're going to look at are hypercalcemia and hypocalcemia. If you wanted to jot these down just as a guide, hyper means elevated levels or high levels of something, and hypo means low levels. So hypercalcemia is too much calcium. Calcemia means calcium levels, and hypocalcemia means too low of calcium. All right. So the on hypercalcemia, and I could have made this a little better, I guess, but hypercalcemia, these are the causes. These two right here are causes of hypercalcemia. So one is hyperparathyroidism. We just at the very end of part two, we said that parathyroid hormone causes an increase in calcium. So if you have hyperparathyroidism, if your parathyroid glands are overactive, you're going to be secreting too much parathyroid hormone. That means that your body calcium is, or your blood calcium is always going to be high because you're absorbing too much calcium, you're breaking down bone tissue. That's going to put you at a risk for osteoporosis. And your kidneys are hanging on to more calcium too. Another big cause of this would be some cancers can cause hypercalcemia. So it can originate in bone marrow, breast, lung, or prostate, but those can all have an effect on your calcium levels. So it says cancer-induced symptoms. If the cancer is the problem, some of the symptoms are weakness, fatigue, impaired mental function, polyuria, which is an increase in urine production, and polydipsia, which is an increase in thirst. So those are all symptoms that are associated with cancer-induced hypercalcemia. Hypocalcemia is low levels of blood calcium, and one of the big reasons for this would be the removal of your parathyroid gland. We mentioned this way back in the endocrine chapter, that sometimes when people would have ablation of their thyroid gland, when part of their thyroid would be removed, the surgeons would accidentally remove the parathyroid gland as well. So if you remove the parathyroid gland, you can't produce enough parathyroid hormone, so your blood calcium levels are going to be too low. Another thing is that you could just be vitamin D deficient. We've mentioned in the digestive chapter that you have to have vitamin D to absorb enough calcium. So if you're not getting enough vitamin D in your diet, you could be eating all the calcium that you need, but you can't actually absorb it and put it into your bloodstream. So this one, it doesn't sound like it's that big of a deal, but this can actually be life-threatening because calcium is really important in muscle contraction. So it can cause muscle spasms. If those happen in your airways, you can have a hard time breathing, or it can also cause cardiac arrhythmias, so irregular heartbeats, just because you can't regulate the muscle control that you're supposed to. In general, the treatment for this is going to be calcium salts with vitamin D. So it's just a nutritional supplement that is going to elevate those levels back to where they should be. Okay, next up, so we've talked about water balance, we've talked about electrolyte balance, so all we have left is acid and base balance. This one's going to be a little bit more detailed, but I want to go over acids and bases and pH real quick. All right, so quick review. I know in Anatomy 1 you probably went over this at the very beginning, but pH is a measure of how acidic or how basic a substance is. And since we're talking about body fluids, we're talking about the pH of our body, the pH of your blood and body fluids. So quick reminder, when you're looking at the pH scale, this is just a number line that starts at 0 and goes all the way to 14. All right, so smack dab in the middle of that is 7. And if something has a pH of 7, that means that it's neutral. So if it's neutral, it's not an acid or a base. So for example, water is neutral because it's not considered an acid or a base, it's just right in the middle. Anything that is below 7 is considered acidic, and anything that is above 7 is considered a base or alkaline. All right, so those are interchangeable. If something is basic, it is alkaline. Okay? All right, so not only anything below 7 is an acid, but the further away you get from neutral, or the further away you get from 7, then it becomes a greater acid or a stronger acid. I use this example in my intro to biology classes, but let's do this number line and pretend that neutral, let's use temperatures, and let's say like 68 degrees is room temperature. It's not hot or cold. Okay, so that's smack dab in the middle. Way over on this side, we could have a temperature of like 0 degrees, and that's definitely cold. And way up here, we could have a temperature of like, let's say 120, and that's going to be way too hot. So 68, that's room temperature, that's neutral. Now, if I jump over to the number line and I get somewhere right around like 60 or let's say 55, that's cold, but it's not as cold as if I got further away and got down to like a temperature of 0. All right, so this is the point that I'm making. 55 and 0 are both technically cold, but 0 is much colder than 55. All right, so let's apply that to pH. Anything below 7 is an acid. So technically 6 is an acid, all right? And 1 would also be an acid. But if we talked about which one is a stronger acid, 1 is a much stronger acid because it's further away from neutral. Okay? 9 is a base and 14 is a base. But if I ask you which one was a stronger base, 14 is a much stronger base because it is further away from neutral. All right? So let's look at what those words mean. If something is considered an acid, that's the substance that releases hydrogen ions. So it releases these positively charged hydrogens when it's dissolved in water. Great example would be something like hydrochloric acid. The formula for hydrochloric acid is HCl, which means it's hydrogen and chlorine. Now, that's what we find in our stomach. If you mix hydrochloric acid with water, it breaks down and it releases the hydrogen. So that's what makes it an acid, is because it lets go of hydrogen, or it releases it. And just like we said earlier, acids are anything that have a pH of less than 7. A base is a substance that is going to release hydroxide ions. So hydroxide is oxygen and hydrogen, and it's got a negative charge. So when they're dissolved in water, they release hydroxide ions. Sodium hydroxide, that's an example of a base. So it's made up of sodium, Na, and then it's made up of that hydroxide ion. So if you mix that in water, it's going to break apart and it's going to release the hydroxide part, and that's what makes it a base. And they all have a pH of greater than 7. And like we said a minute ago, pH of 7, that is considered neutral. All right, so kind of a backwards way to learn this, but the way this works is the more hydrogen ions you release, the lower your pH is. All right, so that's something we're going to kind of go through in these next couple slides. But the more hydrogen ions you release, the lower your pH is. So we need some hydrogen ions. We need to keep a balance, but we have a mixture of acids and bases inside of our body, and those need to be kind of stable and balanced out. So these are sources of hydrogen ions. This is how we can get hydrogen in our body. First up, it says aerobic respiration of glucose. Glucose is the sugar that's found in our food. And aerobic respiration, this is the type of when we break down glucose that requires oxygen. All right. To go way back, if you remember cellular respiration, that was made up of glycolysis and the Krebs cycle, or the citric acid cycle, and the electron transport chain. So the citric acid cycle and the electron transport chain, we have to have oxygen to do those steps. All right, so if you have oxygen and you break down glucose, one of the waste products is going to be carbonic acid, and since it's an acid, it's going to release hydrogen ions. All right, anaerobic respiration of glucose. So if you don't have oxygen and you break down glucose, you're going to make a different waste product called lactic acid. So if you don't have oxygen, you break down glucose, you produce lactic acid, and since it's an acid, it releases hydrogen ions. All right, great example of this is if you see like sprinters, so like really fast short distance runners, they run so fast that they use up all the oxygen and they can't return oxygen back to their muscles in time. So they go through anaerobic respiration and they build up lactic acid. That's why your legs burn when you're running really fast over a short distance, is because you're actually building up acid because you can't have enough oxygen. All right, a few more real quick. Oxidation of sulfur-containing amino acids. So remember, amino acids are the building blocks of proteins. Some of them have sulfur, and when we break those down, it releases sulfuric acid, and acids release hydrogen ions. Incomplete oxidation of fatty acids. So when we break down fatty acids, and we don't break them all the way down, we release these substances called acidic ketone bodies. We'll look at that a little bit later, but acidic ketone bodies, where we break down fatty acids, they're acidic, so they are going to increase the hydrogen ion concentration. So it's going to make our body more acidic. And then lastly, hydrolysis of phosphoproteins and nucleic acids. That hydrolysis means that we break them down. So when we break down phosphoproteins and nucleic acids, we're going to release something called phosphoric acid. And again, it's an acid, so it's going to make our hydrogen ion concentration increase. So all these things that we just went through, those are going to make your body more acidic. All right, we're going to finish. I'll probably have to do like one more part to this lecture, but we're going to talk about the differences between acids and bases. So this is something to keep in mind when we go through this. If something is considered a strong acid, that means that it ionizes more completely. All right, that's a new word for us. So if you want to write this down, ionize means that in water, the substance breaks apart and releases ions. Okay? Ionize means that in water, the substance breaks apart and releases ions. So a strong acid, when it's mixed with water, it's going to break apart and release a lot more hydrogen ions. It's going to release more hydrogen. A weak acid, since it's an acid, it's still going to release hydrogen, but it's not going to break down as completely. It's just going to break down a little bit, and it's going to release fewer hydrogen ions. Okay, so I'm going to jump back 2 slides. If something has a pH of 5, that's an acid, but it's a weak acid. So it's going to break down and release hydrogen, but it's not going to release as much as, let's say, for example, something that has a pH of 1 or 2. That's a stronger acid, so it's going to break down more completely and it's going to release more hydrogen ions. Now the opposite is true for bases. A strong base is going to ionize more completely and release more hydroxide ions. So something that's a strong base is going to break apart a lot more, it's going to release a lot more hydroxide. That's going to make the pH go up higher because bases have a high pH, above 7. A weak base is going to ionize less completely and it's going to release fewer hydroxide ions. So it's still going to break apart and release hydroxide, but it's not going to release as much as a strong base would. All right, why this is important when we talk about regulating our body pH is if we have strong acids inside of our bodies, so one of the things we will do is we can convert that strong acid into a weaker acid. Now, it's still an acid. It doesn't sound like we fixed anything. But if we had a strong acid inside of our body and we can somehow change that to a weaker acid, then that's going to bring our pH back up closer to neutral. That's actually going to raise our pH up. All right. All right, so let's go back to the temperature analogy. If it's, let's say, because it's about to get summer, so it's getting pretty hot, sort of sometimes at least. So if it's warm and like your house thermometer is set on 90 degrees, that's really hot. Like it should not be that hot. Now, if I changed the thermostat to 80 degrees, that's still hot, but it's not as hot as 90 was. So by going from a strong heat to a lesser heat, I've gotten the temperature closer to comfortable. That's the same idea here. If I have a strong acid and I can convert that into a weak acid, then that's a way that I can get the pH closer to normal. So we're going to look at 3 different ways that we can regulate our hydrogen ion concentration, or ways that we can regulate our pH. All right, and we'll look at these in the next part, but quick preview, those are an acid-base buffer system. Buffers are chemicals in your blood that keep pH stable. If you wanted to write that down, that would be good. A buffer is a chemical in blood that helps keep pH stable. So inside of our blood, we have these chemicals that help keep a stable pH inside, keeps it from getting too high or too low. The others are respiratory excretion of carbon dioxide. If we get too much carbon dioxide in our body, we're going to have carbonic acid, and that would be a low pH. So respiratory excretion means that we breathe out carbon dioxide. Lastly is renal excretion of hydrogen ions. So we're going to get rid of hydrogen through our kidneys. So we'll look into more detail of that on the next part.